What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we will be tackling exercise 40 of our Python programming exercise tutorial series. With that, let's get to it. So guys, one thing I should mention, right, is that this exercise 40, it's the last exercise that we are looking at that deals with the concept of loops in Python. So in the next exercise onwards, until further notice, we will be dealing with a new topic. Specifically, we'll be having a look at exercises that deal with functions. So this one is the last exercise for loops. So let's get to it. And guys, if you look at this text prompt, at the text prompt for this question, you'll notice that it's quite similar to the previous question we did, right? With the prime factors. I'm actually recording these back to back, so you'll see there's our output to the previous lecture or program, the greatest common divisor. Now, the reason why I say this program is similar to that one, reason being, they made life a bit easy for us in this one again, and they gave us some pseudo code to follow, right? Because this is kind of a, in inverted commas, difficult or challenging program to do. So what they did is they gave us the logic. All we need to do is take the English logic, the pseudocode logic, and translate it into the appropriate Python syntax to do what it's supposed to do. Now, first things first, right? Let's read this prompt. I don't think we did that. Exercise 40. The prime factorization of an integer n can be determined using the following steps. Initialize factor to 2. While factor is less than or equal to n, do. If n is evenly divisible by factor, then conclude that factor is a factor of n. Divide n by factor using integer division. Else, increase factor by 1. Write a program that reads an integer from the user. If the value entered by the user is less than 2, then your program should display an appropriate error message. Otherwise, your program should display the prime numbers that can be multiplied together to compute n, with one factor appearing on each line. So essentially what this program is asking for, guys, we get these things called prime numbers, right? Prime numbers have only, I think, two factors, if I'm not mistaken, one and itself. Now the thing is, they want us to compute prime factorization. So basically factors are like numbers that can be divided by a certain number entirely, right? And now prime factorization has to do with only getting prime numbers that when multiplied give us, that end number. For example, right, you see the number 6. The number 6 is not a prime number, right? This is an example I'm giving. Number 6 is not a prime number because a prime number only has two factors, one and itself. Now, 6 is just like a regular number, right? Now, using prime numbers, they want us to give the user prime numbers that when multiplied will give us, the resultant number. So in the example of 6, 2 is a prime number, 3 is a prime number. Therefore, we can say, 2 times 2 times 3 is equals to 6. What's another good example? Maybe 14. Let's just try 14, right? I don't think this through. Let's just go with it together. Anyway, 14. How can we get 14 with prime numbers? 2 is a prime number, 3 is a prime number, 4 is a prime number. So let's think it through. 14. If I'm not mistaken, though, it seems to me like 14 can be obtained using 2 and 7. If I'm not mistaken, 7 is a prime number as well. So 2 times 7 is equals to 14. Excellent. That's kind of the logic they want our program to have. The program, apart from, forget the end result, the program should just have the logic to first pick out prime numbers, and then using some appropriate maths, when multiplying it, it should give us the resultant value. and they made life easy for us. It's nothing difficult. All we need to do is translate the pseudocode into the appropriate Python syntax. So let's get to it. First things first, let's set up a variable called n, because remember they told us that have a program that reads an integer from the user, and then they also gave us the name of the variable here, prime numbers that can be multiplied together to compute n, which tells us that n is the integer that's being entered by the user. So let's do a please enter the integer. That's good. Next, we can actually set up a variable, or like a factor or an object, whatever you want to call it, because they said initialize factor to 2. So we'll just set it in lowercase since they told us. Next, let's actually proceed to have a small message. So the reason why we'll print this message at the top is because they wanted each number to show up on a new line, right? So what we can do is just tell the user at this point in the program the prime factors are, or let's say the prime factors of %d are, yeah, and that's good enough. Let's put a ellipsis there just to make it a bit readable, and we'll pass in n. Yeah, that's fine. Now let's do some logic. So easy stuff, nothing difficult at all. While first we need to check, yeah, so let's do this. So first things first, right? We can actually tweak that a bit, but it's fine. We'll follow what they gave us, right? So first things first, if while factor is less than or equal to, and yeah, let's proceed to do it their way. While factor, because there's more than one way to do it. So while factor is less than or equal to n, I'll enclose this in a bracket, make it a bit more readable. While factor less than or equal to n, do. So let's set up an if statement. If n mod, if n is evenly divisible by factor, so mod factor is equal to 0, do conclude that factor is a factor of n. So let's conclude print. In this case, I don't think we should print messages, saying basically essentially what I'm trying to get at is that for each value that's determined to actually be a prime factor, I think it would be kind of ridiculous, to keep printing like, 2 is a prime factor of that, 3 is a prime factor of that. I think what would be much more readable is to just output the values. They'll show up on different lines like 2, 3, and then it makes it much easier for us. So if we were to do the math, mentally, then it makes it easier. So let's just give out the number. They want us to conclude that factor is a factor of n. So we just, in this case, just give out factor. Yeah, that's good. Next, we can actually divide n by factor using integer division. Integer division, that's fine. Integer division is a standard, normal regular division. One is a single division operator is called integer. This is just if you didn't know, right? Extra information. A single one is called integer division, and a double one is called floor division. So that's fine. They wanted us to also divide n by factor. So let's do that. N is equals to n over factor. That's good. Else increase factor by 1. Factor is equals to factor plus 1. That's good. I see I have a flag here. Let's see why this is being flagged. Okay, single equals to, it's supposed to be a double. That's fine. That's all. That's literally all for this program. One thing we can do, just as a safety precaution, because like right, at the moment in the program, if the user enters a number that's less than 2, because like, let's face it, 2 prime numbers start from 2, right? Positive ones. And now if the user enters 1 or negative 1 or 0, then there's no prime numbers for that. So what we can do before the while loop is we can just have one if statement checking if n is actually less than 2. It can be equals to 2 because 2 is a prime number. So let's do if n is less than 2, print there's no prime numbers for yeah, we'll just comma it here and n. That's good. Excellent, guys. Now is the time when we can run the program, test it out, and see if it works. Because essentially, we've successfully translated the pseudocode into Python syntax. We've got it all. Initialize factor to 2. Well, first we take input. Yes, then we initialize. Well, we just have a simple message there. You can, if you want, print this message on or you can omit this message here. This message can be omitted. Then we this is extra, right? Coming from our side, they also told us though, if the value entered by the user is less than 2, so it's a good thing. I actually forgot to even see that. But notice that, out of good coding practice, we also just checked to make sure. So that's good. Then your program should display an appropriate error message. Otherwise, yeah, that's good. Back to the pseudocode. If n evenly divisible, we have that there. Conclude that factor is a factor of n. So we concluded by printing. Divide, the division takes place as well. Else increase factor by 1, and that's done there. So that sums up the program. Let's go ahead and test this. Please enter the integer. I want to do 6 first, right? Because we know in the beginning of this lesson, we checked 6, we did it manually, and we know we should expect 2 times 3. So let's check. And yes, excellent, there we have it. The prime factors of 6 are, so that message we see is really just that line there that we see in the editor. And excellent, 2 and 3. Let's do, this is quite an interesting program because I know in high school and stuff, they made us calculate prime factorization manually, right, using pen and paper and stuff. So this is cool. In our case, we know the logic and we are actually programming a software to allow us to get the prime factors of any number at will. So let's try 100. 2 times 2 times 5 times 5 makes sense. 2 times 2 is 4. 4 times 5 is 20. 20 times 5 is 100. So let's do a large number. I'm thinking let's do a funky one. I don't know, like myself, what prime numbers exist like past 100, because like I am most familiar with the ones less than 100. So let's just do this. Oh, okay, damn, that's cool. 97,943 is actually a prime number, and 3 times that prime number will give us this 293,000 that we entered. Yeah, 3049 is a prime number. Yeah, let's try one. Yeah, exactly. The if statement, the first if statement is enabling us to catch those situations, those that input that does not meet the criteria. So that's good, guys. We've effectively and efficiently completed exercise 40 of our Python exercise tutorial series. Again, I should mention this is the last exercise in the series that deals with loops. The focus of the series or the exercises to come, from the next video onwards until further notice, will look at functions. And with that, thank you for your time, guys. Do make sure to leave a like for the video if you enjoyed or learned something new. Subscribe to my channel. It really motivates me, to keep making more content for you. Apart from that, though, the YouTube algorithm takes those statistics much more seriously than we do. And with that, good luck with your work, and I'll see you in the next YouTube video.